My name is Vishal Sheths. I am one of the partners with the MAHDTM framework. More importantly, as Arturo mentioned today, it's more about sharing information because it's very different. When I asked the question, how many of you have heard of Agile for hardware, I literally saw one hand go up and two, Jake kind of was on the side, but two people had heard of Agile for hardware. And that's what we're trying to change. So we definitely want to make sure that more people are aware that Agile can actually work for hardware. And it's actually pretty cool, especially if you've done a lot of waterfall, or even if you've tried some of the Scrum and Agile techniques. Oh, sorry, I switched, but I'll get there again. But if you've tried Scrum and Agile, you have been frustrated by it, especially when it's a hardware environment. The context is very different. So I'm going to go through that real quick, set up the context, and then we'll jump into it. So these are the sponsors again. This was a slide, so thanks to them, thanks to all of you. I call you all my sharks, because you all voted for me. So thank you for doing that. I'm going to go ahead and the initial slides, I'll go through it faster, but a quick show of hands. This is me. You can find me on LinkedIn as well. So a quick show of hands. Does anybody, do all of you work in some sort of hardware industry?
I worked for Thermo Fisher Scientific, making mass spectrometers.
You did? I was in the CMD division. I actually set up the PMO for them. So that's pretty cool. August spec.
Mass spectrometers.
Yeah. So the CMD was the chromatography and mass spectrometry division that they set up. Anyway, that was the 22, 23. All right. So does your organization build physical products? All of y'all? Okay. And what do you use today? Waterfall?
A printer.
What's the process?
We build the financial statements and print them and mail them to their house.
Oh, okay.
So it's not exactly hardware, but in a mostly fintech company, we have the one hardware that gets sent to someone's house.
But you gotta have it be scalable.
That's right. So mostly I'm just curious because it seems like a fascinating application, and Schwab doesn't actually build hardware.
Okay, interesting. Let me know, we'll go through it and see if there any. So any of this is hardware in our opinion, something physical, and have software, electronics, suppliers, third-party vendors, all of that. A lot of people have used waterfall, they're used to it. It's common sense, it works. For 50 years, this worked. People were building products using this. It may not be the most optimal, but it worked. The challenge is that it tends to assume that the biggest part is up front. You assume requirements, and you assume you understand the problem and the solution, and solving the requirements. Then you kind of start working through it, and then you find that, oh my God, you know what, there's challenges, there's issues. The rubber hits the road, and a lot of assumptions start failing. And so then you have to make some trade-off decisions, typically towards the end, because the integration doesn't happen until the end. Everyone has a Gantt chart. Everyone's going off and doing their stuff in a silo. When they try to put everything together, hey, I built to the spec, I built to the spec. You put it all together, it doesn't work most of the times. And you have to make tough decisions, things to continue to delay, and so on and so forth. So learning happens really late. Limited collaboration because everybody's doing this. Hey, I have my Gantt chart, my plan is here, I'm going to follow it, that's my job. Project managers tend to focus on the plan and say, okay, this is it. Did you get your task done? Done? Great, you're on track. I'm really on track. So, generally speaking, this is kind of a little way to, so I'm going to continue to use this, but the idea is that, if we think about it in terms of certain parameters of what success might look like or optimal project management might look like in a hardware world, waterfall falls short in pretty much every category. So again, we'll continue to build and talk about that. I only have 30 minutes, I'm trying to start getting into the actual math part of it, because that's what will be more fun. Software needed a better way, so then they came up with the Agile Manifest. And they said, oh, we can do this better, which absolutely makes sense. Some of the principles and the ideas make a lot of sense, right? You put the customer first. Process is a tool. So you want to talk about people and collaboration, and you want to be able to respond to change. That was one of the biggest things from a mindset perspective. Completely spins everything around, saying, don't assume that your Gantt chart, which is 2 years, 3 years, whatever the lifespan of your project, that's the source of truth. That's not the source of truth. There's going to be so many changes, everything will change by the time you hit your 3-year mark, or 2-year mark, whatever the timeline is. So let's, in fact, change the mindset. So we assume change is always going to happen, and we're going to figure out a better way to respond to it. So for software, they went ahead and came up with Scrum, Safe, all of those, and it's short cycles, rapid iteration, makes sense, it works. So again, this works for software, and if you look at, essentially, if you look at the Agile for software in the software context, it works because you can do small things. You can build in a little increments. You get some customer feedback. You can do UX design. There's a lot of stuff that actually works. There's better collaboration, all of that. The problem happened when hardware companies started kind of trying to adopt this in their world. Hardware is different. First of all, you build a product, you put it out there, you can't, other than your firmware or software, you can't change it. It's there. So now you mass produced it, it's sitting out there, and you find a flaw, you want to fix it, it takes months and years. It's your next project. 2 years, 3 years, whatever. And so it's a very long cycle. It's going to sit there, which means you cannot just push an MVP out there. You push an MVP out there, it's barely going to do enough. So what we call is, what we encourage is something called OVP, optimal viable product. So think about, yeah, it might have some bells and whistles. Okay, it's got to survive competition and everything else for the next 2, 3 years, 5 years. So there's longer constraints. There's more systems that are electrical, mechanical, controls, instrumentation. There's so many different systems involved compared to software, where you typically could have a full stack engineer and they can do most of the stuff. So there's a lot more skills involved, a lot more collaboration needed. So when they try to put what we call as the square peg in a round hole, so you take Agile for software, Scrum, and you try to apply it to hardware, it doesn't work because the challenges are completely different. When Scrum was built, they didn't have those things to worry about. And it works for software, it absolutely does. So you got to think more holistically, more system level when it comes to hardware. So if I look at basically, if you try to apply Scrum for hardware, certain things do happen better. You have better transparency because you see what's failing. You're going to continue to try and learn. So there's potentially some rapid feedback. But there are other areas it doesn't do governance very well, for example. So for the management, and you have a MAD project, you're like, hey, this is tough. So this is the genesis of MAD. It started around 2016. It is mainly about using some of the Agile principles, but changing the tactics so that they'll work better in the physical development space. That's the basic premise. It takes advantage of a lot of the Agile ideas. So the good thing about waterfall and NPD processes is that they work, but they're great for governance as well. People have used it for governance, and that's governance model. Scrum was a way of working for teams. Say, how do you build stuff? How do you build stuff that actually hits the mark, that meets customer needs? MAD tries to bring the things together. To say, hey, we still need a governance model, because hardware does need governance. It is a much longer cycle. It is a product you can't just keep updating every 3 weeks. And so there's a different way of thinking about it. But we want to take advantage of some of the ways that we're doing that. So it is built on Agile principles of short cycles, collaboration, rapid prototyping, and I'll talk about what that means. In our world, we say fully. It's not rapid in the sense that, hey, you don't build a new prototype every 2 weeks. That's not what we suggest. What we call is flexible fidelity prototypes, which means a diagram on a piece of paper can be a prototype. A 3D printed model of a little component can be a prototype. What you're trying to do is to learn through those prototypes, and that's the idea. So I'll talk more about that as well. But we do want some of the benefits, right, the cross discipline, because there's so many disciplines involved. We want the collaboration to be higher, we want customer engagement, we want shorter learning cycles, so we're learning and making a better product. But we cannot do Scrum for Agile because that's too fast, and we're not able to kind of see how things are building up. Plus, with Scrum, you can do user stories that are more bottom up. You can't see the big picture. So I was telling Jake earlier that I used to work with a UX lead, and he would say, okay, even in software, when there's a bunch of user stories, his comment was, well, you're giving me Lego blocks, but do you need a Ferrari or do you need a Honda Odyssey? How do I know that? Don't give me all this small stuff. Anyway, so the MAHD journey has been around since 2016, officially launched in 2016. It's been around for a while, it's been proven. There's literally an entire complete MAHD model, which kind of goes all the way from portfolio down to the team level. And the thing that's awesome is that it's a single framework that can work from a small team, small project, all the way to like thousands of people on a project. So it's very scalable. The other thing is it's also compatible with stage gates. It is compatible with, if you have a software team doing safe, it's compatible with that. So it's very flexible. That's why it's a framework, because it's adaptable to the needs of the organization. So over the last, 10 years almost, or 7 years, or 9 years, we've done surveys of hundreds of different projects we use MAHD, and typically most people start with, hey, I want to build faster. So we've seen 25 to 50% faster typically on most projects. But then more importantly, we're also building products that are meeting the customer needs, that are focused on customer needs, that are satisfying the customer needs, which is a huge thing. And that's kind of hard to gauge, right? Because you don't have requirements. You're learning with them. All right, so I'll skip through all of that. Okay, there are three things that make MAHD, three big things, which are different, which actually make the MAHD work and kind of find that sweet spot between governance and agile ways of working. So number one is going to be the on-ramp. So the on-ramp is and I'll talk a little bit more about it, but it's a fast start in the right direction. You do want some structure for sure, so there's some planning involved to make sure that you're focusing on the right things. Then there is the IPAC iterations, which are actually how are you going to go work through this. So the IPAC, and we'll talk about the iteration. This is the execution model. How does a team, how does a small or large team build the system iteratively and learn as they go? And then the third part is the backlog. This is the easiest part of the whole thing, is essentially instead of just one giant list of features as a backlog, we actually have a higher level system level backlog, and then a subsystem level or a swim lane level backlog. So it's just easier to kind of manage because the reality is there's always multiple components and subsystems involved. So what does the on-ramp look like? So the purpose of the on-ramp, I'm not going to go into a ton of detail, but the simplest thing is it's a collaboration between the business side of the work, marketing, business, product, who bring in the customer position or view of what's valuable. And then you have engineering that kind of says, hey, what's possible? That's literally the entire purpose of the process, is to say, how do we find this nice collaboration between what's valuable and then what's possible? So there are 5 steps. One thing I'll call out, and without going through a lot of detail, is you start with the system level problem. You always focus on what's the customer need? What problem are we trying to solve? Once you understand that, you're then literally turning the tables around, and the engineering team is saying, what do we think might be an optimal solution here? And you're going to evolve that through the iterative process. Number one thing here, it's lightweight in terms of planning because that's the right way in terms of approach. But the focus is important to say, what are the biggest drops? You all have seen that analogy. A professor kind of walks into a class, puts a jar on the table, has rocks, pebbles, and sand and all. And he says, hey, how do I optimize? How do I fill this entire jar maximally? And what he does is, you start with the sand and the pebbles and stuff, you can't fill it up. You gotta go with the big rocks first, and then you do the next and the smaller things and shake it up and the whole thing gets optimized. That's the same idea. So the focus matrix is a very important step in this whole thing. It's a tactic. You say, hey, what are the big rocks? If this is the problem, roughly, and here's potentially some high-level solutions that we can explore, where do we have risk? Where are my unknowns? Where is the opportunity for innovation? Once you figure that out, then the team can start going through these IPAC iterations. So the best part about this is typically, if you look at a typical waterfall cycle.
So if I'm doing Agile in a software environment, I can use off-the-shelf software to the whole end-to-end process from various third parties. Can I do the same here?
Absolutely. So you can use Jira. if you have it. You can use pretty much any of the project management tools because it's actually very lightweight and can easily be configured. Because all you need from a backlog perspective, Epic's tasks, when you have some higher level user needs, system level stuff, which is actually very easy to incorporate. Which is why I said that the beauty of this framework is it can fit in any organization in any dynamic. So this is very powerful. Sorry.
What is iPack?
I'll talk about that in a second. But the beauty of this is if you have experience with waterfall, you know that there's a process where you write a PRD, when you write an SRD, and you negotiate over stuff. You say, oh, this is possible, this is not possible, and so on. Tell me what your end need. Oh, what's your must-have, nice-to-have, and good-to-have. There's a lot of discussions that happen on paper. A bunch of assumptions go into requirements. This is one thing that is very different from a math perspective. What we're saying is that a requirement tends to mean that the person writing the requirement understands not just the problem, but also the solution. A lot of hardware requirements tend to have specifications built in, which means that's the solution. Now, by the time you build it, what if the market has shifted? What if new technologies have come in? That's literally a product person typically telling the rest of engineering, don't think, I'm telling you what you need to build. Where you're limiting the scope of experimentation and utilizing the skills that the technical team has. And that's what we want to take advantage of. So typically, like I said, with waterfall, lots of negotiation, but it's not collaborative. It's not healthy friction. So in the same time, and then finally they build a Gantt chart. Gantt chart, as you all know, has a ton of buffer, has a ton of assumptions, and it becomes the truth. And it leaves little room for learning. So if you find that, hey, maybe I can find something that, oh, I don't have time, I have to finish this task. And we want to avoid that. We want to let engineering do the right thing and build an optimal product that actually solves the problem in a good way.
So staying back to the conversation that we had earlier outside, where you have an engineering team maybe meet up with the sales team if that's even capable. You say that hardly ever happens. Would maybe a quarterly meeting be possible if you can even make it happen?
It's even more than that. We don't want you to talk to sales. We actually want engineers to be able to talk to the end user. Right? Who's the end user? What is the problem we're trying to solve for them? Because they'll tell you exactly their problem. And the solution might be very different from what the salespeople are telling you or marketing is telling you. Because a lot of people, what they tend to do is, if you're in sales, marketing, product, it's not just about what the customer is telling you, but it's also about what my competition is building. So you're saying, it's kind of a Me Too thing. A lot of features end up being, oh, they have these features. You gotta have them to stand a chance at their next sale. Now, how do you know that's the right thing to build? Oh, they must have done the analysis. Everybody thinks the other person has done the analysis. I just have to do the work, and then that will somehow solve the problem.
Well, I've been in that situation before, and on the customer side, sometimes it's just pricing. And it's not necessarily,
Any constraint?
they're like, well, they're cheaper and we're going to spend money with them just because they're $1,000 cheaper or something.
Right, but then I think on the other hand, you can focus on what's the customer problem they are trying to solve, what's the customer problem we are trying to solve. Even if you only have two things that you're solving for the customer, but those are the biggest problems. There's an example of the Apple iPod versus the Neo. I don't know if you all know, Neo was cheaper, could hold a lot more. It was an expandable SD card and all that kind of stuff. It was around the same time. It actually came out before the iPod. But Apple kind of took a different approach and said, we're going to actually look at a lightweight product that fits in a pocket, holds 1,000 songs. That was their thing. They boiled it down to just that and told engineering to figure out how you're going to make this happen. To the point, they used to carry around these little foam boards or foam boxes with lead weights in it, just to feel it around and make sure that it doesn't feel right. And then that was their guidance to engineering to say, hey, this is what my constraints are. Can you now figure out the details? And so there's a lot of different ways to think about this. Yes, sometimes Me Too is useful and important, but also if you can start with the customer problem, you're going to arrive at a better solution. And then you also want to get customers along the way. So the thing I want to point out in this, typically that entire process of going from ideation to a Gantt chart takes weeks and months with lots of not healthy friction, just lots of negotiation on paper and a bunch of assumptions. With MAD, we actually have the on-ramp. It literally, even for a large, and I'll give you an example. There was a company that we're working with They're literally innovating on a new battery system, extremely complicated stuff, $1 million each. And they want to innovate on that, go from a whole giant battery thing to a modular model. Everything changes, there's connectivity, all of that. And 9 months is what they basically are going to finish it in. A hardware, brand new product, ready for production in 9 months. So the beauty of the on-ramp is that it lets you get started really, really fast in the right direction. Once you're able to do that, it's just powerful because you save a lot of time and you're actually focusing on the big rocks. So that's the analogy I'm going to continue to use, is the big rocks. Okay, so what we have seen, right? Different examples, I'm just going to quickly point it out. 80% faster kickoffs compared to traditional ways of doing it. And this doesn't mean this is completely chaotic. It is very well thought through. It makes sense because, again, if you can figure out the big unknowns first, if you can identify and work on those first, you're going to be in a much better place by the time you're even halfway there. Everything else that remains is going to be stuff that are known entities, things that you know how to do. And so that's one of the big premises here. The IPAC stands for Integration, Prototype, Alignment, and Customer Engagement. I'll tell you what that means. The outer circle is basically what the IPAC iteration is. That's the system level iteration where you're focusing on the whole. You're focusing on the big picture. Hey, what is this customer need that we're trying to solve at the big picture level? You're going to then prototype. So part of that outer circle is to say, hey, we're going to do these little prototypes that help us learn. So the big rock, once you figure out what the big rocks are, the prototype is going to be a way to learn to say, hey, how do we uncover this? There's an unknown here. How do we understand this and address it? And then you're going to continue to kind of go back to the customer. So the customer engagement is to say, hey, customer, is this on the right track? Do you think we're building something that makes sense that you would use? So before you go too far, you're taking many steps along the way. That's one way to think about it. It doesn't mean you need a full-blown prototype. I'll go back to that flexible fidelity prototype. That's what you're looking for. And then the alignment, again, there are lots of different groups involved. How do you align across that? So the idea is, at the holistic level, you are aligning with the electrical team, with even manufacturing, marketing. It could be a third-party vendor, because you have a dependency. Hey, this is what we're thinking, this is where we're going. Do you think you'll be able to do this at a certain point? And then the smaller sprints are essentially where the teams go off and they can build or work on their subsystems and such. This is how, by the way, these are flexible, which means you can have 1 sprint, 2 sprints, 4 sprints within an IPAC, which is important because in hardware, sometimes if you're getting a board built somewhere, right? A PCB board takes a while to come back. And it could be part of your prototype, it's going to take some time. So that's why it's flexible, because teams can kind of say, hey, I need a little bit more time for this one, but that's how we're going to do it. And so there's a little bit of flexibility there. This is what makes it work for hardware. As you can see, the idea is that you have the big rocks, you have an idea of what you're trying to solve, and you start iterating, and the picture emerges. This picture of the solution that makes sense emerges. As it emerges, you take it to your customers, and you kind of get something to say. Because again, customers need to see something. Anything, even if it's a 3D mock-up, that's something that they can give you some feedback on. So that's the idea. One other thing, constraints. I forgot to mention that earlier. But hardware is full of constraints. It has to be compliant to ISO 27001. It has to be cost. You mentioned cost. Hey, it needs to be cheaper than this as far as to make it profitable and worthwhile. And that's all okay. So the best thing about that is you start with those constraints, and then as you work through these, you take attention to the constraints and saying, okay, what trade-off decision do we make? The whole thing, the IPAC cycles are all about trade-offs. You're learning, you're making trade-offs. You're learning, you're making. So this is what it will look like. The best picture that I have come across so far that we built that actually explains this entire model. You start with essentially a vision brief that tells you, hey, directionally, what is the problem we're trying to solve? What is the market segment we're going after? What are some of the constraints? It's literally a one-pager. And you provide templates for that, but nevertheless, it's a one-pager. Then you do the on-ramp, where the team actually takes that and says, okay, if this is the problem we're trying to solve, what are the big blocks? What are the things that we don't understand that we might want to innovate on, that we might want to, that there are unknowns and risks around? So then they think about, okay, what are the prototypes? So the divergence convergence is important, and that's the agile thinking. Is to say, we don't know the optimal answer. We're going to explore the big rocks. We're going to try to figure out where to pay attention, what we're learning. So you diverge, you try maybe 2 or 3 different things, you decide, and you say that's your trade-off, and you converge. You might have a couple more questions that might reveal. And so you're going to okay, let me try that. So that's the whole divergence convergence model. Initially, you're going to spend a lot of time on investigations, because that's your unknown. Those are your big rocks. As you address your big rocks, you get to a point where you start becoming very predictable. So what's left is stuff that the team already has done before. So most of the own stuff. That's the power of how we've incorporated Agile into this. Obviously, it's a mindset change. There's a certain amount of changes that have to happen. But another company where we work with, overall, they got about a 33% faster time to market. So because they were able to get started faster, pay attention to where they needed to change, where the big rocks were. This one's the easy one, so I'm going to skip through it, but it does answer your question. It's literally, you can do it even on a spreadsheet, epics and tasks and subtasks, and it's very easy to incorporate into anything. The swim lanes and so on and so forth, but it's all pretty easy. The thing I did want to call out is, MAHD is a framework, is a tool. It is not something, we do not believe that it should be used as dogma. The idea is that it's a tool. You need to adapt it to your organization. And for every project, you need to figure out, what is it that you want? You want faster speed? You want higher margins? It could be a cost reduction project. That's okay. And so the framework needs to work for all of those scenarios. So in this scenario, this company was like, hey, we're generally fine, but we want to reduce our costs. So we want to focus on the trade-offs that will help us with better margins. And so that's what they focused on. Overall, with traditional, what you tend to find is that when you build a Gantt chart, there's a lot of comfort. Like, oh, we have a plan. This is so good. It looks so great. And there's all these nice waterfall and things happening. When the rubber starts hitting the road, lots of trade-off decisions. There's always change management is a pain, because one thing changes, especially in hardware, 3 other things have to change. So there's a lot of impact downstream. All of that makes it very messy. And so that all of that discussions happen. Trade-offs, generally, integration tends to happen later on. You might build an alpha prototype, but typically it's a full-blown prototype of the entire system. That's the first time that the team starts integrating the whole piece. And that's the challenge. And what that does is it tends to then, you find the hard stuff later, and then you have to make trade-off decisions. The idea with MAHD is that we're going to attack the big rocks first. The biggest risk, we get it. We don't know much stuff about the solution, and that's okay. We actually don't even know everything about what the customer needs are, and that's okay. We know the hype good enough so that we can get started quickly. We're then going to incorporate, we're going to learn as we go, the big rocks, and as we learn, we're going to ask the customer, is this the right thing? Do you think we're on the right track? And that's how you get to a better product. So essentially, by the time generally what we've seen is 1/3 to halfway of the way down, most of your risk is pretty much figured out. And then it's just straight down. But this is the idea. Probably, okay, almost at time. So Agile for hardware, it doesn't mean there's no schedules, it doesn't mean there's no plan, it doesn't mean unlimited flexibility. This is what scares people. Oh my God, Agile means everything's going to keep changing all the time. That is not the intent. That is not the idea. Let's just kind of look at, hey, where's the big rocks, what's changing there? It does mean getting more comfortable with unknowns, starting with a few more unknowns, because that's also your big rocks. Lots of learning. So initially, especially as you go through your initial cycles, you're going through the learning mindset. You say, these are the things we don't know, how do we think we can optimally solve it? Short cycles as much as possible, engaging with customers. So there's a few things, even empowering teams, that's a hard thing, it's like it used to be, you have a Gantt chart, and now the project manager is like knocking on your door every other day saying, hey, are you done, are you done, are you done? That's not very powerful or useful. Okay, so Again, in our opinion, what we've seen and experienced, it's still not the best thing out there. There's always room for improvement. So, based on the Agile principles, MAD, Modified Agile for Hardware Development, has done a good enough job in every different perspective, every different area that we can think of. There's still some areas that we could continue to be better, especially the portfolio side and so on. So that's pretty much it. Yes, I might have gone a minute or two over, but mathframework.com. We do have a lot of free material you can kind of download, ebook, 4-minute video. There's a bunch of webinars on YouTube as well if you want to dive deeper. But if you are in any sort of hardware development, I encourage you to at least take a look at it a bit more deeply. Feel free to connect. I'm happy to kind of have other conversations. But bottom line is, we haven't done this a lot before. It's been around for a while, and there's a lot of we haven't done a ton of marketing. So we've now kind of gotten into the point where we're like, hey, let's talk more about it because it's pretty mature, it's pretty proven, and we're pretty passionate about it. It's kind of like once you drink the Agile Kool-Aid, you don't want to do anything else any other way. But thank you all for joining. Appreciate it. If you all don't mind,